My name is Jonathan Afek, and I work on the Watchfire security team. I'm going to present to you research we did about dangling pointers. So, dangling pointers is a well-known class of vulnerabilities, but so this is not new. But what is new is the 3 new exploitation techniques that we have researched and developed at Watchfire. And on top of that, I'm going to show you a real-world dangling pointer vulnerability in the IIS 5.1 web server, and I'm going to show you how to remotely exploit it. So, let's begin. First, I'm going to tell you what is a dangling pointer. Explain what is this vulnerability. Afterwards, I'm going to talk to you about some technical background needed in order to understand the exploitation techniques, and I'm going to show you the exploitation techniques themselves. Afterwards, I'm going to show you the demonstration of the remote exploit. Then I'm going to talk a bit about what can we do in order to defend ourselves. Then I'm going to summarize and let you ask some questions. So, actually, this presentation is going to be technical. I'm going to explain all the things needed in order to understand this presentation, but it is technical, so pay attention to the details. So, what is a dangling pointer? Actually, every dereference of a pointer that points to invalid data is a dangling pointer vulnerability. I'm going to talk about a specific dangling pointer vulnerability that I'm going to show you with the next animation. So, let's imagine an application that has 2 pointers, pointer 1 and pointer 2, that each one of them points to a different data object. Every application has some pointers and some objects, and this is just an example. Let's imagine the application executes the next line of code. This code creates a new object instance in the application's memory, and a new pointer called pointer 3 that points to this object. Now, after the application finishes to use the object, it deallocates it from the memory in order to save system resources, because the application needs to save memory. But the pointer is still in the memory and points to a place that has no longer valid data. So this is a dangling pointer. Now, when the application uses this pointer, it actually... what's that? Okay, so we got a crash. So this is the usual behavior when you try to dereference a pointer that no longer points to valid data. So a bit about exploitation. I'm going to show you 3 exploitation techniques, actually. And a common thing to all of these exploitation techniques is that... what is that? That we're going to intercept in between the deletion of the object and the execution of the virtual function, the function that relates to this object, and overwrite the object, the memory location where the object used to be. So in order to illustrate it, I'm going to show you an example. For those of you who are unfamiliar with VMware, this software enables me to run another machine on top of my Windows XP. So here I have a copy of Windows XP that only has the only thing that I did on it is install IIS 5.1 on top of it. This Windows is fully patched as of last month. And it is vulnerable to the dangling pointer vulnerability that I'm going to show you in a moment. So I'm going to browse to this web server, to the IIS web server that is on top of the inner Windows. I'm going to call this the VMware Windows. So I'm going to browse to the web server that it runs. Just a moment. Okay, so the only new thing that I have put inside the web server is an ASPX, just an example ASPX page. It could have been any other ASPX page. And besides that, it's just the default installation of the IES server. Okay, so I browsed to this ASPX page, and this communication with the web server made it allocate a new object. If I just send 3 more requests that looks like this, it deallocates the object and still keeps a pointer that points to it. So now I have a dangling pointer inside the application's memory. Okay. Now I'm going to make the IES server execute a virtual function that relates to this object, and we're going to see the results. Okay, so this is the behavior I talked about earlier. This is what usually happens when you try to execute virtual functions using a pointer that no longer points to a valid object. Okay, so as I told you before, all of the exploitation techniques that I'm going to talk about, in all of them, I override the object in this place. I'm overriding the place where the object used to be with my own data, and therefore I can make the application use my own data as if it was the object. A few things about dangling pointers. As I'm going to show you, dangling pointers are very dangerous, and I think most of them can be exploited for arbitrary code execution. So they are exploitable, and there is a good methodology in order to exploit them. And they are common. As I've talked to many C++ developers, I realize this kind of bug is very common, and sometimes it is even harder to detect than regular buffer overflows and other bugs. Because sometimes the application won't crash when you execute the virtual function and will just look like as nothing happened, but you can still exploit it. Okay. So a few things we need to know before we can talk about all the exploitation techniques. A few terms. The first one is memory layout. So we need to understand that each application has a memory layout and that it has memory addresses. So let's take, for example, the memory address that you can see on the left, 00920050. This address points to the beginning of this buffer. It points to the byte 45. These are all hexadecimal digits. So each 4-byte value can be treated as a memory address and can actually represent a place in the memory. In the rest of this presentation, I'm going to use the size 4 bytes a lot of times. So whenever I say a D word, you probably know it. I mean 4 bytes. Another thing is registers. Those of you who are not familiar with the term registers, registers are CPU variables, actually, that can usually, to simplify things, they can hold D-word values and can hold pointers to places in the memory. Okay. So as I told you before, I'm going to inject new data instead of the old data that used to be to reside in the memory. And in this section, I'm going to show you what is the new data that I need to put instead of the old one. So before we begin, we must first talk about how does an object instance look like in the memory. So let's take, for example, this class definition. Okay, so now we have the definition of class A. It has an integer member, 3 virtual function, 1 static function, and 1 regular function. Okay? This is how an instance of this object looks like in the application memory. So each rectangle in this small rectangle in this diagram represents a D word, and I'm going to start from the left to the right. So the most left thing in this diagram represents the instance itself of the object. As you can see, the static functions and the regular functions are not in this diagram, and they do not reside inside every object instance. The first D word of every object that has virtual functions is a virtual function table pointer. Okay? And after that, we have all the variables of all the members of this object. So the virtual function table pointer actually points to the virtual function table. This is the thing that I'm pointing out. The virtual function table resides of addresses of all the virtual functions of this object. As you can see, the first D word of this table has the address of the first virtual function. The second D word has the address of the second virtual function. And the third D word has the address of the third virtual function. Okay, so let's see what actually happens behind the scene when the application executes this line of code. It actually is compiled to something very similar or equivalent to these assembly lines. So whenever an application uses an object, it usually points to the beginning of the object with ECX. ECX is a register that can hold a D word value, that can hold a pointer in the memory, and it usually points to the beginning of the object. The first assembly line makes EAX, which is another register, point to the beginning of the virtual function table. And the second assembly line actually executes the third virtual function code, because EAX points to the beginning of the virtual function table. EAX plus 4 points to the second D word of the virtual function table, and EAX plus 8 points to the third D word of the virtual function table, and that is the address of the third virtual function code. Okay, so this is how objects are implemented. Now I'm going to show you the first exploitation technique that I'm going to talk about. In this exploitation technique, I'm going, as I did before, to make the application allocate an object. I'm going to make it deallocate this object. Afterwards, I'm going to overwrite the place where the object used to be, and then I'm going to make it execute a virtual function.